All right, gave you some different diagrams up here for Riemann sum. Riemann just means we're using rectangles. Now, the reason that we use rectangles to estimate the area under a curve is because the rectangle is a simple area formula. Base times height or length times width. Very simple formula to work with, okay? The diagrams that I drew, in each one, I just put 3 rectangles, just to kind of give you an example, okay? We could have 3 rectangles, 4 rectangles, 20 rectangles, 80 rectangles, okay? But if we can do it with 3 or 4 or 5, then we obviously know what we would be doing with 60. It would just be a lot more work with 60. It's kind of the general idea, okay? So we're approximating with rectangles, and basically what we're saying is, if I want to have the best area possible, then these rectangles that I would draw up here, how close do they need to be to each other? How small do they need to be? Minuscule. Yeah, infinitely small, right? So if I had something like this and made them a lot smaller, it'd be a lot more rectangles, but it still wouldn't be perfect. You're still either going to come from one side and not have quite enough coverage, or come from the other side and have more than you need. So the width's got to be infinitely small, right? And that's what we would call an infinite Riemann sum. Now, an infinite Riemann sum is what we're going to deal with in a different class. We're just working with a finite now. So we need to understand that if we're doing a finite number, then it's going to be an estimate. Okay? Typically, it is called a lower or an upper estimate, because you either have more than what's actually under the curve. So we got more space here. Or I don't have enough. I left some out. That would be a lower. Okay? The only way that you can look at it and tell if it's an upper or a lower is if you actually draw it out. And you can see the space that's left over or how much extra you have. All right, so generally what we say is we are looking for a left or right or midpoint. Sometimes, and I drew the diagrams both ways, sometimes the left can produce a lower, and sometimes the left can produce an upper. It just depends on the way the curve's going. That's what's creating that. But when I'm thinking from the left, I'm drawing that top of the rectangle from each left side. Right could produce an upper, could produce a lower. And midpoint, it actually could produce a lower or an upper, but it's really tough to tell because I don't really know, are these spaces equal or not, and it depends on the curve. I mean, we'd like to say that they're equal, so it'd actually give you a pretty accurate area, but we know they're not equal necessarily. Okay. But I think when you look at that diagram, even with 3 rectangles, this midpoint probably gives you the best approximation of the 3. You should have some things kind of canceling out here. That's the general idea we're working with. Everyone okay with that?
Yeah.
All right. How do you find area of a rectangle?
Times width.
All right, length times width. So area of a rectangle. All right, this equals length times width, or also say base times height. Same thing, right? Not gonna matter. Okay. So when I'm thinking about a rectangle drawn inside a curve, and it doesn't matter which way the curve goes. I know I kind of have the same diagram up here. It really doesn't matter, okay? It's just a curve. So if I picture a rectangle here right in the middle, and I draw it from that left side, this would be the width, this would be the length. Width of the rectangle, the length. Or this would be the base, this would be the height. Everyone okay with that?
Yeah.
Now, this right here would be a function value. All right, so let's put some numbers in here. Let's say that this was a 3 and this was a 4. That would mean the base is 1, or the width is 1. You want to agree with that?
Yep.
That would mean the length or the height would be f of 3. The y value at 3. Of course, I need an equation here and all that, but you see where that's coming from. Okay. Now, if I draw this from the right, just to kind of give you an example, now my height or length moves over here, and it becomes f of 4. Does that make sense to everyone? If I did it at the midpoint, it would be f of what? 3.5. F 3.5. You're right in the midpoint between 3 and 4.
Wait, how is f of 4 lower than f of 3?
Because on the right side, that y value is lower than f of 3. This y value is lower than that one.
Oh, I see. It's okay. All right.
Starting from that right side. Are you okay there? Okay, now let's get an equation up here. And then we'll kind of play with those rectangles a little bit. All right, let's say we have a region bounded by f of x equals x squared plus 4, and the x-axis on 0 to 4. So say part A. Left Riemann using, and we'll say 4 rectangles. Left Riemann using 4 rectangles. So that means we're going to add up the area of the 4 rectangles under that curve. Now we don't really need to draw it. If it helps you, you can draw it. Here we've got x squared plus 4. You should remember that as being a parabola. Moved up 4 units. That sound familiar? Okay. And start at 0. I'm going to go over here 1, 2, 3, 4. And there's where my rectangles are going to come in. See my 4 rectangles there. I usually go by a number line. I say a number line because the x-axis is a number line. So if I am going from 0 to 4, there's 0, 1, 2, 3, 4. Well, there's 1 rectangle, 2 rectangles, 3 rectangles, 4 rectangles. That means the width of each one is 4. Everyone agree?
Width of each one.
Excuse me, 1.
Yeah,
Total's 4. Width of each one's 1, yes. All right, so I've got 1. So we're going to have 1 f of 0 plus 1 f of 1 plus 1 f of 2 plus 1 f of 3. Now, base is all 1. 1, 1, 1, 1. The heights, or the lengths, whichever way you want to think of it, f of 0, f of 1, f of 2, f of 3. Why am I not including f of 4?
This is only 4 rectangles.
So that's from the left. So my first rectangle is between 0 and 1. What's the left side? 0. My second rectangle is between 1 and 2. What's the left side? 1. My third rectangle is between 2 and 3. What's the left side? 2. Fourth rectangle is between 3 and 4. What's the left side at 3? Everybody okay with that? All right. Now let's kind of calculate this out. One of the things I can do, I'm just going to go right here. I can actually factor that 1 out. So the way that we'll typically see it written would be like this, with that 1 out in front. And the reason I can do that, now it's not always going to be a 1, but the reason I can do that is because the width was the same, or the base was the same of each one of the rectangles. They were all 1. All right. So f of 0, 4. F of 1, 5. So I've got my function. F of 0, 0 squared plus 4. F of 1, 1 squared plus 4 is 5. F of 2, 8. And f of 3, 9 and 4 is 13. Let's see, what would that be? 9, 8, 7, 30? Does that sound right?
Yes.
Yeah, 30. So 30 square units would approximate the area under that curve using 4 rectangles from that left side. Are you okay there?
Yeah.
Would we have like units squared next to it?
Typically we'll have units squared or square units. We don't really have to put anything if there weren't any given. So if it was in inches, I'd have square inches or something like that. Right? We're working on that value. So I'm going to keep the same setup here. Right. This time we're going to go right Riemann using, let's go 2 rectangles. So we're still on the interval 0 to 4. We're going to have 2 rectangles this time, coming from that right side. Now, a lot of times where we end up having trouble is in the width of the rectangle or the base. Okay? This one's pretty easy because it's a 4-unit base. There's 4 rectangles. That makes them each 1. Not so bad there. Okay? The width comes from b minus a over n, that base or width. The interval is the a and b. So if I subtract my interval, 4 minus 0, divide by the number of rectangles, that would give me 2. That means each width is 2. It would work the same back in this one. 4 minus 0 is 4. Divided by 4, 1. Okay? But this a lot of times would tell me how to kind of draw that number line. Right? And I say that number line, but along that x-axis. So I'm going to have, let's see, 0, 2, 4. There's my 2 rectangles. My width was 2, counting by 2. Everybody okay with that? All right, so width is 2. So we're going to have 2 times f of 2 plus f of 4. So this time I skipped that first step. I just went ahead and factored the 2 out. So that 2's coming out, because that's going to be the width of each one anyway. 2 times and 2 times. Not a big deal there. Right? Why the 2 f of 2 and f of 4 and not f of 0? Right side. So I'm just visualizing, all right, here's my rectangle going up. Base is 2, and then this would be the height. That f of 2, whatever it is. Same thing, here's my second rectangle. There's my base 2. There's my height f of 4. So you don't really need the full picture to kind of see what's going on or where you would be at. This is just going to kind of represent that x-axis and tell you where you're at. So my calculations, f of 2, let's go back into my function here. That would be 8. And then 4 would be 20. And so 28 times 2, 56. Now, a very different answer there than the 30, but that's because we went from 4 rectangles to 2, so you're getting a lot of extra space, you know, as far as what's happening in these gaps here, however the graph is drawn, but we're definitely seeing that piece there. Okay? And that's why you're getting some variance in the answers. It's still an approximation. I don't have any clue at this moment what the actual area is under this curve, okay? But I know that 30 is a better approximation than 56 only because there's more rectangles. The more rectangles, the better approximation. Okay? So I want you to realize it's still going to be an approximation. We're not going to ask you to do 20 rectangles. It's a lot of work. If you could do, like I said, 4 or 5, then you could do any of it. Okay, let's change our region. Let's go region bounded by f of x equals x cubed on, let's go 2 to 12. So then we'll go part A on this one. Let's go, okay, you want to go left or right this time? Left? All right. Left, Riemann, using, let's go with 5 rectangles. Using 5 rectangles. All right, so I need to figure out my width of each one first, or my base. Okay. B minus A over N. So that would be 12 minus 2 over 5. That would be 2 units. Everybody agree with that? 2 units? Now if you figure that part out first, then when you come over here and draw the number line, I just went right here, it tells me what to count by. So I'm starting at 2, not 0 this time, and I'm counting by 2s. So 4, 6, 8, 10, 12, and then I can see 1, 2, 3, 4, 5 rectangles. Are you okay there? Okay. 2 would be the width, and it's the width of each one. So I'm going to go 2 f of, now would I start with f of 2 or f of 4? 2, because I'm on the left side. There we go, f of 2 plus f of 4 plus f of 6 plus f of 10, and then that's it. No, I missed 8. One of those days, I guess, right? There we go. 2, 4, 6, 8, 10. Now we get the general idea here. Okay, so we're not going to bother with the calculations. We can just go through and kind of do some other setups, because f of 2, I'm going to put 2 in, 4 in, 6 in, calculate it out. Everybody okay with that? Okay, so now let's look at this same problem. And let's go midpoint Riemann using 5 rectangles. Well, I still have 5 rectangles, so that means the width's still going to be 2. Everyone agree with that? All right, so let's just pretend we hadn't done part A yet. That means my first step is to figure out my width, B minus A over 5, or over N. So 12 minus 2 over 5 is 2. That gives me my number line. 2, 4, 6, 8, 10, 12. Width is 2. But this time it says the midpoint. So I'm going to have 2 times f of, what's the first value going to be? 3, because that's the midpoint between 2 and 4. So my width is, or my rectangles between 2 and 4, width 2, f of 3 plus f of 5 plus f of 7 plus f of 9 plus f of 11 are the midpoints. And this part right here, I don't think is necessary, doing this mock x-axis kind of thing, but I think it definitely does help with the setup as far as what you're looking at. You can see what the midpoint value is. Now, if it ends up being a decimal, sometimes so be it. It's a decimal. Big deal. Okay, let's go right. Riemann using 3 rectangles. All right, so then the first step again, how wide is each rectangle? All right, so I've got to figure out that width, that b minus a over n. 12 minus 2 over 3, what's that, 10/3, right? Right? And I know, kind of a pain if it's a fraction, right? But we're going to count by 10/3. It's not as bad as you think. If I know that the width is 10/3, my start was 2. It was the interval 2 to 12. I know I erased this, but it was the interval 2 to 12. Right? Well, let's put that in thirds. Just rewrite it as 6/3. Are you okay with that? Now the width's 10/3, so that means the next one is 16/3. Then what's the next one? 26/3. And the last one, 36/3, which is 12. That was that ending p. So if you end up with a fraction, a lot of times we think it's going to be horrible. Just go ahead and change that first number, whatever it is, to that same denominator, because then you're just counting by that. You have all the pieces, right? Your width is 10/3. F of, would I start with 6/3 or 16/3?
16/3.
16, because it's on the right side. Plus f of 26/3. Plus f of 36/3. Now I know finding the values might be a little bit of a pain, but you do have a calculator. I mean, you can put that in and get the value that you need. Okay? Setting this piece up is key. And usually what happens to a lot of us is we get something like this. And we start to worry about, how do we split that up? What's the next value going to be? Easiest thing, change whatever this first one is to that denominator. Then you're just counting by that amount. You have everything set up. Yeah, you're probably going to need a calculator to go get these values because it was x cubed. But that's not too bad. Something like that. Everybody okay there? All right. Let's get the homework then.